Thursday of next week. All right, welcome back, everyone. Math 131, Lecture 14. We have just had Test 2. Test 2 ended at 4.3, the derivative of y equals e to the u, where u is a function of x. And we started just a little bit with a quick review of our natural logarithms last time. This is really last time, but 4.4 is where Test 3 begins. So be sure to look at Lecture 13, where we quickly went over a little bit of natural logarithms, but I'll pick up with that again today as we review. I like to do 4, 4, 4, 5, and 4, 6 all together. It just is a nice little flow to do it that way, and we have an hour and a half so we can do it. So we're going to do just a quick review of our natural logarithms again. I've already pointed out the identities, but just want to say it once again, and the properties. Then we want to look at the derivative of y equals natural log x. That is the variable x, not a function of x. And then we want to progress to the derivative of y equals natural log of u, where u is a function of x. And I bet everybody thought as soon as they saw me do that, you're thinking chain rule. Remember, u might be 3x squared plus 2. It is not the variable x, but a function of x. And we'll go there, and then we'll be experts in natural logarithms. Okay? We're getting close to the major, there are really two major parts in calculus, derivatives and applications. So now we've done algebraic functions, derivatives, and applications. Now we're looking at exponential and log derivatives and applications are coming up in Chapter 5. And then the second biggie of calculus is anti-differentiation or integration. So after we do a little first two sections in Chapter 5, then we jump to Chapter 6 and start the second big topic in calculus, anti-differentiation or integration. Okay, so we're getting close to the second big topic. All right, let's pick up at what we were talking about last time, our review of natural logarithms. You may want to look back in your notes of what we did. But one thing that we said in last time was to recall that f of x equals e to the x, the natural exponential function, and g of x, which is the natural log function, are inverse functions. They're inverse functions of each other. And we pointed out on the calculator the second button over the natural log. The second button over the natural log is the e to the x button. They're inverses, second functions, inverses of each other. We looked at the graph last time to see how it reflected across the line y equal x, or you interchanged x and y. A couple things we noticed was that the natural log of 1 is equal to what, everybody? 0. The natural log of e is equal to 1. I mentioned another identity, and I used words that said, using the definition of inverse functions, when you form their composition, you got the x back. And there were a few glazed looks in my audience here when I was talking about that. I don't know if it was because it was test time or what, but let me just say what I was saying again. You have a definition about inverse functions, and it says that when you form the composition of inverse functions, you get back what you started with, like f composed with g at 3, you get back 3. Or g, this is definition of inverse functions. Or if you form the composition g at f of x, you get back x. And I said that, but I was not quite sure you remembered that from your pre-calculus, so I decided to do it from right here. F of g of x is natural log x. So I just replaced natural log x for the g of x. And now I'll go to my f function, and where I have an x, I'll put in natural log x, e to the natural log of x. So by definition of an inverse function, this has to equal x from right here. So that was one of the identities. you might have e raised to the natural log of 3. That would be equal to 3. That's easy to show on your calculator. Let's just do it. I'm going to do e raised to the natural log of 3. So e raised to the natural log of 3. And when I enter that, I got 3. They're just inverses. They cancel each other out. So e raised to the natural log of x squared plus 3 is x squared plus 3. Okay, the other part to the definition of inverse functions is that when you form the g composed with f of x is e to the x. So g evaluated at e to the x is natural log e to the x. And because they are inverse functions, this has to equal x. And that was one of the other identities that we looked at in lecture 13. Okay, and you can, it just means that if you have the natural log of e to the 10th, that will be equal to 10. And again, you can just verify it on your calculator. Of course, one example is not enough to verify it. I use the definition, and that's why it's so. But if I do natural log of e raised to the 10th, and there's my 10 right there. Okay, so just putting in some numbers, you see that. All right. The other thing I mentioned in the last lecture that we're going to need for today's lesson, some people call it laws of logarithms. Some people call it properties of logarithms. And because I like to use these as I'm explaining e to the u, I'm going to mention these early, even though your book keeps mentioning it early. They don't really tell you where it is until you look in section 4.6. But again, these were properties that you learned in your pre-calculus class. The first one is that the log of a product, natural log of m times n. And the reason that you have this property is because you remember the natural log is saying what is the power that you raise something to, so you relate it to exponents, and you know when you're multiplying with like bases, what do you do to the exponents? You add. So basically the log of a product, when you have your like bases, you're going to add your exponents. So it's natural log of m plus natural log of n. And you can just quickly show it to yourself with an example. The natural log of 6 is equal to the natural log of 3 plus natural log of 2, because 6 is 3 times 2, for example. All right, we're on our calculator. Oops, quit. All right, natural log of 6 is 1.7917 something something. Okay, natural log of 3 is 1.0986 something. Anybody know the natural log of 2 without me putting it in there? That's a popular one. It's pretty close to 0.7, 0.69. Natural log of 2 is 0.693. So if I add that to the 1.0986, there's my 1.7917. So just sort of verifying. If you put numbers in, you have it. Okay? You okay? All right. That was your first property. And that came from a to the m times a to the n. When the bases are the same, you added your exponents, and you can convert from log form to exponential form, and that's where it's coming from. Okay, natural log of a quotient. And that's where you have like a to the m divided by a to the n. What do you do to those exponents? Subtract. So you have natural log of m minus natural log of n. An example might be natural log of 16 thirds. That's going to be equal to natural log of 16 minus natural log of 3. All right, let's do the right side first. Natural log of 16, so I don't have to rewrite it. Can you see it? 2.7725 0.88 minus, so I'm taking my answer and subtracting the natural log of 3. And so the right side is something like 1.67398. I rounded it. And now we'll take the natural log, parentheses, 16 divided by 3. And you get the very same number. If you can see my calculator, you can see they're exactly, there you go, exactly the same. Okay? All right, so that's just properties of your logarithms. One more. The natural log of m raised to the p, that's like when you have a raised to the m raised to the n power of a power. You just multiply the exponents, so it's p times the natural log of m. Now this is, I don't know why I did two equal signs. This is not equal to natural log of m raised to the p. It's not equal to natural log of m raised to the p. It is the m itself that is raised to the p. Okay, so you have to watch that and be careful with it. All right, here's your example. Do you want to make up an example, or you like what I'm doing? Natural log of what power would you like? What would you like to do? 3 raised to what power? 21. Okay. All right. Is that equal to 21 times the natural log of 3? Okay, so let's do it on the calculator just to sort of show. I'm going to do first 3 raised to the 21st power. Whoa, that's a big number. Okay, then we're going to take the natural log. Can you see it? Natural log of that answer. And we get that it's 23.07085, whatever. And then the other side will be 21 times the natural log of 3. And we better get the very same answer. And we do. Okay, everybody good? Properties of logarithms. All right. I'm still saying again what we said right at the end of class last time because we were thinking test. We used our identities to solve equations. And the best I could tell, you did great with that. An example would be 3 times the natural log of x is equal to 5, and we're wanting to solve for x. Okay, and when I teach a pre-calculus class, the first thing I'd say to my students is this an exponential equation or a logarithmic equation? And you would say logarithmic, because it's got a log in it, right? It's got a log in it. And the only way you're going to be able to get to that argument x is to let both sides of the equation be the exponent for e. But let's go back to that identity. I think that's 2 pages back, right? The identity is that e raised to the 1 natural log of x is equal to x. The example that's right here, if I want to raise e to both sides, that's 3 natural log of x. So to apply the identity exactly, I need a 1 in front of the natural log of x. So what do I need to do before I let both sides be the exponent for e? I need to divide both sides by 3. And so now I have the natural log of x equals 5/3. Now I'm ready to apply the identity that e to the natural log of a is equal to a, because that will help me get to the x. So I'm going to exponentiate both sides of the equation. Let both sides be the exponent for e. So e raised to the natural log of x is x. So x is equal to e to the 5/3. So when you have a logarithmic equation, in order to get to the variable, you have to do the inverse function, which is exponentiate. All right, when you had an example such as, I copied these out of the book, I think. E squared raised to the x times e to the natural log of 1 equals 4. Seems like this was like number 35 in the exercises, best I remember. All right. When you look at this problem, would you say that's an exponential equation or a logarithmic equation? Exponential, because you got the base e in there. So usually when you have to solve when there's a variable up in the exponent with an exponential equation, you're going to have to use the identity that the natural log of e to the a is equal to a. All right, but before you start, it's not in that form, natural log of e raised to the a. We see some things here we need to do this problem. What about e raised to the natural log of 1? Okay, e raised to the natural log of 1, you can either use this identity and know that's 1, or you could say the natural log of 1 is equal to 0, e to the 0 is 1. All right, so we get 1. And here's a e squared raised to the x equals 4. All right, now how are you going to deal, that's times 1. How are you going to deal with e squared raised to the x? Power of a power? E to the 2x. All right, properties of exponents. E to the 2x equals 4. All right, now we have an exponential equation. Exponential equation, the unknown is up in the exponent, and we're reminded of the property that the natural log of 1 times e to the a is equal to a. This is 1 times e to the a, all right, e to the a. So in order to get to that exponent, we do its inverse function by doing what to both sides of the equation? Natural log. Natural log. So now we have 1 natural log e to the a corresponds to the 2x, so this simplifies to 2x equals natural log of 4, so x is equal to natural log of 4 divided by 2. Okay, how's that, everybody? Good? All right, and just remind me one more time, what does the graph of y equals natural log of x look like? It's the inverse of the exponential, so yes, very good, very good. It's going to go through 1, 0. It looks like this. Okay? All right, that's basically your graph. What does y equal e to the x look like? Yep. Let me do that in green. This is y equals natural log x. Y equals e to the x. Exponential, growing exponentially. Y equals e to the x. Okay? All right, we're ready for the derivative, I think. All right, and this happens to be section 4.5. 4.5, we want to find the derivative of y equals natural log of x. All right, and this one's pretty easy to derive. Instead of me just telling you this is what it is, I thought that you might enjoy me showing it to you. And anytime a math person is going to try to prove something new, you always start with what you already know. So I would say, so far, we know the identity y equals e to the natural log of x equals x. And this is going to be the part here that's going to help me come up with the derivative of y equals log x, because we already know how to take the derivative of e to the u, where u is a function of x. All right, so I'm just going to split up these equal signs here to two parts. First of all, I'm going to say y equals e to the natural log of x, and I'm going to say y is equal to x. Because I just said, I said y is this e to the natural log x, which is equal to x. All right. Now, if I take the derivative of the part on the left, I'm going to have to use my chain rule, right? The derivative of e to the u is equal to what? E to the u part times the derivative of the u part. Well, if we knew what that was, we wouldn't be solving this problem, right? Okay, so all I've done so far is just the chain rule. So you guys could have done this if you'd been born centuries earlier and gotten your name published. All right. Now let's come over on this side, because these two things are equal. We know that dy dx is equal to what? 1. So dy dx from right here is 1. So I got 1 equals. Just going to make some substitutions now. This may make some of you decide to be mathematicians if you think this game is fun. And what did we say e to the natural log of x is exactly equal to? X. All right, so that's exactly equal to x. So we have x times the derivative of natural log x over dx with respect to x. So what would you say the derivative of natural log of x with respect to x is? 1 over x. All right. So if y equals natural log of x, the variable x, we have that the derivative is equal to 1 over x. Okay? That's not too bad. We know the derivative e to the x is e to the x. The derivative of log x is 1 over x. Okay? We haven't gotten to the chain rule part yet. All right. Let's do some drill. Everybody say, what's the derivative of natural log x? You tell me. 1 over x. What's the derivative e to the x? E to the x. Okay? All right, let's do some drill. Find the derivative. Find the derivative. All right, number 1. Y is equal to 7 times the natural log of x. Y is equal to 7 times natural log of x. Okay, impress me. What is it? 7 over x, or 7 times 1 over x, which is 7 over x. You already had the property that when you have a constant times a function, the derivative is the constant times the derivative of the function. How many got that right? Make me feel good. Whoa, what did you do wrong?
I never know how to sort it.
Okay, but you know if you had something like y equals 7x squared, your derivative is 7 times the 2x. Okay, so it's 7 times, it's a constant times a function. Okay? All right, everybody good? All right, let's go to the second example. Y is equal to e to the 3x times natural log of x. Wait, read that to me. E to the 3x
Times.
natural log x. What rule are you using?
Hold on.
Y'all are good, good, good. Go for it. Actually, I'd like somebody's work so we can edit it if necessary. Can I use yours? All right, let's look at this and see what we think. All right, y equals e to the 3x times natural log of x. The first times the derivative of natural log x. Would everybody say correct so far?
Yes.
Yes. Plus the second function, natural log x, times the derivative of e to the 3x is e to the 3x times 3. What do you think, everybody?
Yep.
Perfect. All right. Great.
Leave it like like it is right above the last line, right?
Well, if the problem said simplify, this is about all you can do right here anyway. Well, actually, if it said factor completely, you see that e to the 3x is a common factor in both terms. So if it said that, you could factor out an e to the 3x, and that would give you 1 over x plus 3 natural log x. And that would be about what you would do. Okay. Depends on what you need it for. If you were looking for possible extreme points, it's going to be easier to see what makes the function equal to 0 or undefined. And it's only undefined at x equal to 0 there. But that's not part of the domain, so this problem wouldn't have been good anyway. Okay. Good job. Perfect. Perfect. All right. Anybody have questions about number 2? All right. Number 3. Y equals natural log of x, the whole thing raised to the 10th. Y equals the quantity natural log of x raised to the 10th. And you had very good notation there too. Thank you. Who's got it? Perfect. I'm going to use yours. All right, let's see if we need to edit this answer. Okay, the first thing you noticed was you had something raised to the 10th power. Did everybody think general power rule? So the derivative, that's a y prime there. The 10 is brought down, rewrite, decrease by 1, derivative of the inside. Everybody happy? Let's write perfect on here. Perfect, perfect, perfect. Okay. All right, next example. Would you pass that back? Thanks. Number 4. Everybody get it right? Number 4. Y equals e to the 4th plus natural log of 7. Y equals e raised to the 4th plus natural log 7. Who's got it? What'd you get?
E raised to 4.
Is that 1 over 7?
1 over 7? How'd you deal with that e to the 4th? That's just a number, so the derivative of a number is 0. Natural log of 7, that's just a number, isn't it? I don't see any x's there. Natural log of 7, that's just a number.
Oh, okay.
The derivative of a constant is 0. Who got that right? Yes, I could look at your face and, is that he the only one that got it right? You, well, we'll make a crown and put on your head. Good for you. All right, everybody good? All right, if you missed it, you want me to send around the red pens? All right. Next example. What would this be? Problem number 4 or something by now? 5. Example number 5. I'm trying to do every kind that could be a problem, potential problem. Natural log of x over the square root of x squared plus 1. Natural log of x over the square root of x squared plus 1. I want to hear you say this one. Natural log of x divided by Okay, what rule are you using? Yes, very good. Go for it. All right. Have you got it? Thanks. All right, let's look at this and see what we think. I'm just so proud of you guys. I'm seeing everybody using proper notation. All right, quotient rule. The bottom, or low for you yodelers, the bottom, which was written to the 1/2 power, times the derivative of the top, 1 over x, minus the top, times the derivative of the bottom. Anybody see anything here? Okay. Yeah. Bring the 1/2 down, rewrite exactly, decrease by 1, and then derivative of the inside over the denominator square. If you square 1/2, it's going to be equal to 1. Are we good now?
Yes.
Okay, we'll go almost perfect. Okay? All right. I'm sure you just forgot that. You were so concentrating. All right, everybody good? Any questions on that, anyone? Everybody good. Okay, you ready for the challenge of all challenges? Yes. All right. I want you to think about what you're doing. I have faith that you're going to get it because you got the other one. All right. Y equals the natural log of 3x. Y is equal to the natural log of 3x. And if you'd like, brainstorm with your neighbor. You haven't seen one like this.
And then and that's just a number.
What'd you
So
get?
that was 0 plus 1 over x. Yeah.
Maybe not.
Yeah, that's what I meant.
1 over 3x.
Okay, I'm going to read this one more time just in case you're not following my little rules. This is the natural log of 3 times x. Does that sound like any little property you might know?
Yes.
What was your property?
Ln 3 plus 1 over.
Natural log of 3 plus natural log of x. This was your property of exponents. Remember, when you get ready to take the derivative of a function, you can change the appearance of that function, simplify it or whatever, as long as you're staying within your same domain. You can simplify it and then take the derivative. So I'm just using my properties of exponents. So I have dy dx. The derivative of natural log of 3 is 0. The derivative of natural log of x is 1 over x. Is that what you did? Yay! How many did do that? You did, you did, you did? Great. Well, I thought I was going to trick you, so let me try again. 7. Y is equal to the natural log of x over 4. Y is equal to the natural log of x over 4. The natural log of x divided by 4. What'd you get, everybody?
1 over x.
1 over x. This is natural log of x minus natural log of 4, just using my property. So the derivative is 1 over x. All right, one last one, and then we're going to head to the chain rule, which these could also be done by the chain rule. All right. Problem number 8, I think. Y is equal to the natural log of x squared. Y is equal to the natural log of x squared. Okay, I'm going to ask you to tell me I did a perfect job or edit what I do. All right, so I'll put a big question mark here. All right, is the derivative this?
No. Wait.
What am I thinking if I did this? Yeah, I would be thinking that my function would be y equals natural log of x, the whole thing, squared. All right, so that is not the derivative here, correct? All right, here it's only the x that's squared. These are not equal to each other. Okay, all right, so you tell me what to do.
Y is equal to.
Okay, use your properties of logarithms. Bring your 2 down in front. And now the derivative. You have a constant times a function. So the derivative is 2 times the derivative log x, which is 1 over x. 2 over x. What happened if I tried to use a product rule here? Would it be okay? Sure. Let's pretend we're going to do the product rule. You have the first times the derivative natural log x is 1 over x, plus the second function. Derivative of 2 is 0. That cancels out. You got the very same thing. So you can't miss it, right? All right, well, these were pretty easy because I was able to apply the properties of logarithms to get it in a form that ended up with a natural log x in it. But everything's not always natural log of x. So the question is, now, how do we deal with something like y is equal to the natural log of parentheses x squared plus 3x plus 1, the natural log of some function of x, all right, where it's no longer the variable x, but now a function of x. And we recall, you always try to relate to what you already know. When you had y equals e to the x, it was just the derivative was e to the x. But when you had the derivative of y equals e to some function of x, how did you deal with it? Okay? All right, so let's think chain rule. So basically, we have y is equal to the log of u, where u in my case is what? X squared plus 3x plus 1. Okay? And we need the derivative of y with respect to x. But the way I have it set up here for understanding is y is the log of u. So y is a function of u, and u is a function of x. So to find dy dx with the chain rule, we'll find the derivative of y with respect to u, dy du, du dx, times the derivative of u with respect to x. Okay? All right. So if y is a function of u, what is the derivative of natural log u? 1 over u, right? If it were y equals natural log x, the derivative would be, the derivative of y with respect to x would be 1 over x. but y is a function of u here. So the derivative of natural log u is just 1 over u. Okay? So we have 1 over u times the derivative of u. Well, u is in terms of x, and its derivative is 2x plus 3. 2x plus 3 right here. All right, but we're looking for the derivative only in terms of x, not u's and x's. U's were our own creation to help us see how to do it. So we want to substitute back. U is x squared plus 3x plus 1 times 2x plus 3. And some people will write this as 2x plus 3 over x squared plus 3x plus 1. Okay? All right, so when it's no longer natural log x, but natural log of some function of x, you may just want to remember it this way. It's 1 over that function, 1 over that function, times the derivative of the function. 1 over it times the derivative of it. Okay? All right, let's go back to the last couple examples we did, and let's use our chain rule and see that you get the same thing without using the properties of logarithms. Okay, let's jump over here and do the chain rule. By chain rule, all right, the derivative of log u, I'm just going to keep it together. So the derivative of log u, what are we going to do, everybody? 1 over it times the derivative of the function, which is 3. And what happens to those 3's in this case? They cancel out, and there's your 1 over x that you got. Okay? The derivative of log u is 1 over that function, u, times its derivative. Okay? Next example. This part's still my u. By the chain rule, the derivative is 1 over that function, right? Times the derivative of 1/4 x. What is that? X over 4 is the same thing as 1/4 times x. Times 1/4. Okay. Now 1 divided by x over 4, remember you invert and multiply. So this is 4 over x times 1/4. And the 4's cancel out, and there's your 1 over x that we got right there. Okay? Everybody good? Okay, let's look at the next one. And let's use the chain rule. Here's my u part. Let's do it in orange so things look different. Let's try it now with the chain rule. The derivative, it's natural log of u. So the derivative of natural log u is, say it so you'll remember it, 1 over it times the derivative of the u part, which is 2x. And let's see how that simplifies. You have an x in the numerator, an x squared in the denominator, so we'll have 2 over x, which is what we got right here and right here. Okay, everybody got it? All right, so ready for some hard ones? I'll start easy and not go too hard. All right, so the derivative of log u is 1 over the u times the derivative of the u part. Okay? Let me look in the book so I don't jump too hard too fast. Okay. All right. I'm looking at exercises in 4.6. Oh, 4.5 exercises. And I'm going to look for something. Okay. This is number, Wow, I love some of these. I'm going to jump on number 20 right to start with, then I'm going to back up for some other ones. Y is equal to the square root of natural log 2x. Okay, I'm on page 268. Number 20, y is equal to the square root of the natural log of 2x. Who's got it? Carrie, you want to show me yours?
Yes.
Adele, will you take it from him?
I don't think it's right.
All right, let's see. All right, first of all, y equals the square root of natural log 2x. You rewrote it to a 1/2 power. All right. What rule, when you see something raised to a power, what rule do you start out with? General power rule. So I don't think you started out with general power rule. Let's put this in orange. General power rule. All right, so when you have a quantity raised to a power, start out with that general power rule. Send that back, try again. Okay, somebody else send me one up. Okay, great. We take his, Carrie. Okay, let's see what we have here. All right, y equals the square root natural log 2x, rewrote it as natural log 2x raised to the 1/2 power. Okay, the derivative, the 1/2 is brought down, rewrite, decrease by 1, derivative of the inside. The derivative of log u is 1 over the u times the derivative of the u part. What do y'all want to do here? Happy or what? Okay, the 1/2 was down, rewrote, decreased by 1. Is this part right here the derivative of natural log 2x? Is it 1 over the 2x times 2? So what do you want me to do? Big check with perfect. Extra perfect. Extra perfect. All right, now while we're here, let's just clean it up a little bit because sometimes this may not look like the answer in the back of the book or you may need to do something with it. All right, do you see that? Do you care if I write in ink on your paper? Is this okay?
Yes.
Okay, thanks. The 2's divide out. Okay, and it looks like, I'll see if I have a different kind of pen to write with. Your work's so nice and neat. All right, so simplify that negative 1/2 exponent's just going to send it down in the denominator. Square root natural log 2x. That's that part. And this 2 is in the denominator. And that x is in the denominator. And there's a 1 in the numerator. So it's not too bad to clean up, is it? So your line just kind of goes like this. And so you got a 1, and then you got a negative 1/2 carried down, square root, you got a 2 and an x. Perfect. It's not too bad to clean up. Yes? 2, where did it come from? When you take the derivative of natural log u, it's 1 over the u times the derivative of the u part. That's the chain rule part. So the derivative of 2x is 2. Is that good? Let me write on a piece of paper. If, just pretend you had y equals natural log 7x. The derivative log u is 1 over that u times the derivative of this part, which is 7. Chain rule. Okay? Perfect. Send that back. All right, next example. I was just prompted to this example. Find the derivative. By looking in the book, I was prompted to an example like this. Find the derivative of natural log of e to the 3x squared. Y equals natural log of e to the 3x squared. Very good. Very good. Very good. Who recognized this as a property right off? The natural log of e raised to the a is a, right? So this is the very same thing as 3x squared by using your identity property. That's 3x squared, so dy dx then is 6x. Check. All right, could you have done it without using that? Sure. If your brain had not had enough caffeine, which happens to me all the time, the derivative of log u is 1 over that u times the derivative of the u part. Well, the derivative of e to the 3x squared is e to the 3x squared times 6x, right? Derivative of e to the 3x squared is e to the 3x squared times the 6x. And then these parts will cancel out and you're at 6x. Okay? All right. Let's try number 18 right out of the book. Just ran out of paper. Okay, this is page 268. We're in set 4.5 and this is number 18. Y is equal to parentheses natural log parentheses e to the 2x plus 1 and the whole thing is squared. Alrighty, what rule are you starting out with? General power, because you have a quantity raised to a power. Everybody see that? Why did I not just write this as 2 natural log of e to the 2x plus 1? Okay, it's not just that argument raised to the second power, but the whole thing raised to the second. Okay, everybody got that? You didn't get tricked? All right, so we're using the general power rule to begin with. So I'm bring the 2 down, rewrite exactly, decrease by 1, and now I'm ready to take the derivative inside. The derivative of natural log of a function is 1 over that function, right? I hope during the test your brain sees me going 1 over, okay? 1 over that function. What else? Times the derivative of that function. And what's the derivative? E to the 2x? 2e to the 2x. And the derivative of 1 is 0. Correct? How is it? All right, if we were going to clean this up, there's really not much cleaning up to do. You just get 4e to the 2x times the natural log of e to the 2x plus 1 all over e to the 2x plus 1. There's not much you can do cleaning that up. Okay? All right, I see one more in this particular exercise before we move on that might catch you if you're not careful, so let's do it together. Everybody good on this? All right, and just let me make a note again. This is not the natural log of e to the 2x plus 1 squared. Okay, it's not that. It's the whole thing that's squared. All right, one last example from here before we move on. This is example number 12, same exercises. This is problem number 12, and we're on page 268. And it's y equals natural log of x divided by natural log of 2x. Should I ask you to read this for me? Natural log of x. Everybody say it. What rule are you going with? Yes. Just think if I were there on the test telling you, read the problem. Then you'd all be getting them correct. All right, by any chance, did anybody, there's a big question mark here, did anybody write this as natural log of x minus natural log of 2x? What would this be equivalent to if you wrote it like this?
Natural log of x over 2x.
Yes, this part is equal to natural log of x over 2x, which is not the same thing as natural log of x over natural log of 2x. So it is not equal to that. Glad to know that not a single person did that. Sometimes people mix up their properties. All right, so you went with the quotient rule, I think. The low or the bottom, natural log 2x, times the derivative of the numerator, which is 1 over x. Now you do realize, don't you, that this is natural log of 2x times 1 over x. This 1 over x is not multiplied inside the argument here. Okay. All right, the bottom times the derivative of the top minus the top times the derivative of natural log 2x. What's that? Yes, 1 over 2x times 2. Okay, so 1 over 2x times 2, which you could just write as 1 over x. That's pretty easy to figure out. Over natural log of 2x, and it's the whole thing that is squared. Okay? We are good, right? All right. The next little part I'm going to teach you by letting you use your great critical thinking skills, because I have faith that you can figure this out on your own. I'm actually in section 4.6 now, but don't look ahead. Do not look ahead. Do not flip those pages. All right. Our instructions would be still to find the derivative. And we want to think efficient and effectively. All right? And my first example is this. Y is equal to the natural log of parentheses 3x plus 1 times, can I go hard?
Yes.
Thank you. Times the square root of x plus 2. All right. We have to find the derivative of the log of 3x plus 1 times the square root of x plus 2. And we all agree that that's not a very good looking problem, correct? I mean, it looks like it's going to be a huge mess. If we did the derivative as we see it, it would be the natural log of 1 over this thing, and then we'd have times derivative of this thing, which is a product rule with a general power rule involved. Do you see it? Okay. But remember that if we can ever simplify our expression first, then when we take the derivative, it's already in a more simplified state. Does anybody have any suggestions how I might rewrite this so it looks really simple and easy?
Plus.
All right, so it's easier and more efficient if we simplify using properties of logarithms first, then take the derivative. All right, so applying the properties. Now, I'm not taking a derivative yet. All I'm doing is changing the appearance. And you just told me that because there's a product, you would rewrite this as the natural log of 3x plus 1 plus the natural log of the square root. I'm going to write that as a x plus 2 to the 1/2. Okay? All right, all I've done is applied the property of logarithms that when you have a product, you can add. Do you see another property I can use? How about this 1/2? It's the x plus 2 raised to the 1/2. What can I do with it? Move it in front. Okay, have I taken the derivative yet or only applied properties? I've only applied properties. Okay? Now, does that look easy to take the derivative of compared to what we had originally? I'd say yes. Go for it. Okay, what is the derivative of natural log 3x plus 1? 1 over the 3x plus 1 times 3. Did anybody leave that times 3 off? That's your chain rule. It's 1 over your function. Do not forget to then multiply it times the derivative of the function. Okay, then we got a plus 1/2 times the derivative of log x plus 2 is 1 over that x plus 2 times 1. Okay, so if you wanted to see it looking prettier, maybe, it would be 3 over 3x plus 1 plus 1 over 2 times x plus 2. Okay, are we good? All right, how would you like to go for a really hard one? Sure, I love it. I'm going to pull it right out of the book so you don't think I'm being mean. It's coming right out of the exercises. Everybody got this? Okay, and I'm going to go hard only because you're begging me. All right, this is from the exercises 4.6. I'm on page 273, and I'm going very hard, and we will feel very good when you get it. So it's y equals the natural log, big square brackets, x to the 5th times e to the 4x times the square root of 3x plus 1 divided by 1 minus x squared. And the instructions are to differentiate. Do I need to say any more? It's the natural log of the big quantity x to the 5th times e to the 4x times square root of 3x plus 1 divided by 1 minus x squared. All right, enjoy it with your neighbors. Ooh, I love those words. Say it louder.
I feel good today.
You feel good today. You feel good today. Good.
I'm just trying to put them in two separate rooms. So it's not as confusing.
Take your time when you are breaking it down so you don't make any mistakes. Okay? Do one line at a time is what I would say. All right, do you have it written out in simplified form using your properties of logarithms? That's the hard part, right? All right, I'm going to put in every step because sometimes when you skip steps, mistakes are made. First thing you notice is that you have a log that's a fraction. The argument's a fraction, a numerator divided by a denominator. So the first property, if you were going to put in every little step, is it's going to be the log of the numerator minus the log of the denominator. Now you may have skipped over some of these steps, and that's okay. I just want to make sure that we're all straight. I'm going to write that as a 3x plus 1 to the 1/2 minus the log of the denominator. So the property I just used is the natural log of a over b is natural log of a minus natural log b. Okay, if I were putting in every little step. Everybody see it? Here's my A part and my B part down here. Okay? And then the thing you notice is in the first natural log, the argument is a product. So I'm using the properties natural log of A times B, so we add all those together. So we have natural log of x to the 5th plus natural log e to the 4x plus natural log of 3x plus 1 to the 1/2. And then we go minus natural log 1 minus x squared. Okay? I use the property natural log of a times b, natural log of a plus natural log b. Okay? Now, do you see anything else I can do to further simplify it? Good, good, good. I can't tell you how many people don't recognize that identity. I always put this on test. It's one of my favorites. All right. You recognize that identity. Now, I'm going to do everything at the same time. Is there anything I can also do with natural log of x raised to the 5th? Okay, you have your property that, good, that natural log of a raised to the p is equal to p natural log a. So we will have 5 natural log of x plus, and then you recognize the identity here, that's equal to 4x. Natural log of e to the a is a. Do I need to pass around a pen if you didn't recognize that? Anybody? Bring the 1/2 in front using this property. And then we got minus natural log of 1 minus x squared. Okay. All right, so far all we've done is what is called pre-calculus, right? We used our properties of logarithms to get it in its simplest form. And you always wondered when you were studying it in pre-calculus, why do we have to use all these properties when we can just punch things in the calculator today? All right, now we're ready to take the derivative. So you finally had a reason for doing it. All right. Any questions on the simplifying? Remember, I have not taken the derivative until I finish simplifying. All right, what's the derivative of 5 times natural log x? 5 over x. The derivative of log x is 1 over the x, and then the derivative x is 1, so you still can use your chain rule there. All right, and the derivative 4x is 4. I'll do the hard one. Derivative 4x is 4. Okay, plus 1/2 times 1 over 3x plus 1 times 3 minus, what is it? 1 over 1 minus x squared. What? A negative 2x. Negative 2x. All right, and that negative times the negative there is going to make that into a positive. Okay, so the negative times the negative turns that into a positive, and that's about all you can do. That's about it. Now that wasn't too bad, was it? Actually kind of fun?
We just have a test
Good work.
this kind of bad.
That didn't
I have a question.
Okay.
Alright, in the original equation,
derivative of that.
or second
Like 1
part,
over.
you subtracted
Factored 1 over that
the whole inside by
times the
the
derivative
denominator.
of this, which was
Right.
and you didn't carry the parentheses down,
and
does
then
it really matter?
this is harder, honestly.
Yes.
That way. Because then I brought that down.
No, that was really just kind of a grouping there so that you knew, okay, here's your question. That's a good question because it does look a little confusing. If I had written it as log of 1 minus x squared without the parentheses, then the 1 would have only gone with the log.
No, that's not my question.
Down here, do I have to continue it?
You see in the third line, up one. Alright, the first part was the sum.
Right.
And does it matter if that you don't have the parentheses around?
Oh, the whole thing?
Yeah.
In this case, it didn't because there wasn't like a negative sign out front. But, you know, if in doubt, put them in. If you did parentheses there, that would be fine. Because it's this minus this part. But because there's not any negative out here, you're allowed to remove the parentheses. Was that your question?
Yeah. So if the larger part was in the denominator, would it matter then?
Oh, yeah. Oh, yeah. I just got your question. Good thinking. If it had been something like the natural log of x squared over x cubed plus 1 times e to the 3x, for example, when you use your properties, you would have natural log of x squared minus, and you will have to use parentheses, natural log of x cubed plus 1 times e to the 3x, and then just, I'm going to keep going. Are we okay? And then you have big brackets, natural log of x cubed plus 1 plus natural log of e to the 3x. And see, that negative then has to be distributed through. So since if I had 2 factors in the denominator, I would definitely have to use big brackets there. Okay, so this then comes down to natural log x squared minus natural log x cubed plus 1 minus natural log e to the 3x, which we know is a 3x there. Okay, that was your question, right? Yes, thank you. I see where you're going now. Yeah, if that had had 2 factors down there, I would have had to be really careful with parentheses. So if in doubt, put them in. Okay? All right, everybody good with that? Would you like one more? I'm going to show you the exercises. We're on page 273, and I'm going to let you pick the one that you would like to do. Page 273. Which one of those would you like to do together? Oh, 43 through 50 is called logarithmic differentiation, and that's not a required objective of the course, although it's great fun. So you don't see any logs in there. And what you do is you take the natural log of both sides, and then you have to do differentiation and converting it back. So it's here. It's a very good thing to do, but it's not included in Math 131. Okay, so one of these up here, we already did 40. See one here you want to do quickly? How about 39? That's a little different looking. All right, 39, and then we'll claim you're an expert. You'll never miss another one. That's what we're going to claim. Oh, I lost my black pen. Must have fallen on the floor. All right, number 30. This is page 273, number 30. 39. Thank you. Y is equal to the natural log, big square brackets, 5x plus 1 times 4x plus 1 times the natural log of x all over square root of 2x plus 1. Okay, go for it. Okay, how's my simplifying? Okay, where I had a product, I added. Where I had division, I subtracted. We good? I sort of skipped all the steps in between, but it was a numerator minus a denominator. Then I had a product, and then there was one with a power. All right, you don't let things like natural log of the natural log of x scare you, because you just follow the rules. Life would be great if everybody follows the rules, right? Anybody letting this bother them? No, you're not. If you have the natural log x is just a function, right? So the derivative of log of a function is times. See, you don't need me. Okay, go for the derivative, and then I'll catch up with you quickly. Then we'll have to stop for today. I'll be sad. Okay, let's go together. The derivative of log of a function, that's all it is. Log of a function is 1 over that function, and what else? Times the derivative of that function. In that case, it's just a 5, right? Plus, the derivative of log of this function is 1 over that function times the derivative of that function, which is 4. Everybody got those two correct? All right, so we don't worry about things in the next one. We just follow the rules. The derivative log of a function is 1 over that function times the derivative of that function, which is 1 over x. All right, then we got minus 1/2 times 1 over 2x plus 1 times 2. So this little term right here just simplifies. Most people write it as like this, 1 over x natural log x. Okay? That's usually the way you write it. Everybody good? Are you happy? You can do it? Can we call it a day? Check. We're done. Have a great day, everybody.